1-6, solving systems of linear equation notes. So here we are going to solve systems of linear equations by both graphing, elimination, and substitution. 3 different ways: graphing, elimination, substitution. Okay, so first right here, we are going to solve by graphing. Okay, when we are solving systems of linear equations, if the lines intersect, we will have one solution, like the example below, and we would say it's consistent and independent. Okay. If the lines are the same line and they lie on top of each other, we would say they're consistent and dependent. And then last here, if the lines are parallel, they never cross, there's no solution, we would say that they are inconsistent. Okay? So that first example on the graph there, you can see they intersect at -3, -3. So that would be the solution. There's one solution, so it's consistent and independent. All right, stop talking. All right, so example 1 right here, 3x plus y equals -2, okay? So graphing, I need to get this first equation and isolate the y to put it in slope-intercept form. So I'm going to subtract 3x. I get y equals -3x minus 2. So my slope, -3 over 1. Y-intercept, 0, -2. Okay. Down 3, right 1 would be off the graph. So I also need to go up 3, left 1. Okay, to get that first line. All right, my second line, 6x plus 2y equals 10. Again, I need to isolate the y, so I'm going to subtract 6x. Gives me 2y equals -6x plus 10. Divide by 2. My y is isolated. Y equals -3x plus 5. So what do you notice about these two lines?
Same slope.
Same slope. Do they have a different y-intercept? So what are these lines? They're parallel lines, so they never cross, so it's inconsistent. Good. You can just write incon with a period or inc with a period. You don't have to write the inconsistent all the way out. All right, number 2 right here. First line, I need to subtract x. So I'll give me 2y equals -x plus 5. Divide by 2. Y equals -1/2 x plus 2.5. That will have a negative. There you go. Get that negative on there, sorry. Y-intercepts at 2.5, and I'm going to be down 1, right 2. Down 1, right 2. My next line, so because of our reflexive property, we can take that and just flip it. Makes it a little easier. -6y equals 3x minus 15. So from there, I would divide -6, which gives me y equals -1/2 x plus 2.5. What do you notice about these two lines? They're the same. They lie on top of each other. So there'd be infinite solutions. So it will be consistent and dependent. There are infinite solutions there. All real numbers. All right. Number 3. right, so right off the bat, looking at that line, 2x minus 3y equals 0, 4x minus 6y equals 3, what would happen if you multiplied that first line by 2? Except for the 0. So right off the jump there, you can tell that these are going to be parallel lines. Okay, they're going to be parallel lines. So we'll get through this one pretty quick. They're going to have the same slope and different y-intercepts there. Okay. Same slope, different y-intercept. Go ahead and get this down and write it down, but I don't want to spend too much time on this. That should be -1/2 at the bottom. And that line should be close. But up 1, right 2. Ooh. Up 1, right 2. Up 1, right 2. Down 1, left 2. Okay, so
it's still 2/3. That's the slope.
I'm sorry. I'm like losing my mind right now. Up 2, 1, 2, right, 1, 2, 3. Down 2, 1, 2, left, 1, 2, 3. There we go. All right, so next, try and do number 4 by yourself. Try and do number 4 by yourself once you get this down. All right, so for number 4, I want to subtract 2x, negative y equals negative 2x plus 3. Divide by -1, we get y equals 2x minus 3. So y-intercept at -3, that'd be up 2, right 1, up 2, right 1, and I would have my line. My second line, I will subtract x, which will give me 2y equals -x plus 4. I'll divide by 2. I get y equals -1/2 x plus 2. So my y-intercept is at 2, and I'm down 1, right 2, down 1, right 2, and I have my point of intersection right there at 2, 1. So that would be consistent and independent. Consistent and independent. We have a point of intersection at 2, 1 there. When you get this down, do number 5. When you get this down, do number 5. All right, so this first line, I would just need to subtract 4x. So I'd have y equals -4x minus 2. Y-intercept at -2, and I'd be down 4, right 1, which would be off the graph, or up 4, left 1. I would have that line. Now for my second equation, I subtracted 2x, which left me with 1/2 y equals -2x minus 1. And then from there, I multiplied by 2 to isolate the y, which that gave me y equals -4x minus 2. So they have the same slope, same y-intercept, So another consistent dependent there, okay? And do the last one. So here, first line, subtract 3x, negative y equals negative 3x plus 2. Divide by negative 1, y equals 3x minus 2. So my y-intercept is at negative 2, and I'm up 3, right 1. Up 3, right 1. I have my line. And then my second equation, all I have to do is subtract x. Y equals negative x plus 6. So my y-intercept is at 6. 1, 2, 3, 4, 5, 6. And I'm down 1, right 1. Down 1, right 1. And I have my intersection there. So that solution would be at 2, 1, 2, 3, 4. 2, 4. 2, 4, and it is consistent, independent. All right, so the next part in solving system of equations is to do substitution and elimination. We'll start with substitution. Okay, so on the board here, I will work 2x minus y equals 9. And I'm just going to do it on the board so you can see it, but it'll be the same way as that's in the notes right there. So it's all written out in the notes for you, so you can just watch right here and pay attention, okay? So we got 2x minus y equals 9, and x plus 3y equals negative 6, okay? So the key to isolating, or the key to substitution is we want to isolate one of the variables. So I'm going to do what the book did. You can isolate the x or y. If I was working this out, I honestly would isolate the x here and substitute that way, just because it's one step. But the book here did 2 steps. So they subtracted 2x, got negative y equals negative 2x plus 9. But that y is still not isolated, right? We need to divide by negative 1. And so I would have y equals 2x minus 9, okay? Same equation, same line. I've just now isolated that y, okay? So from there, I'll take 2x minus 9 and plug it in for y on the other line, okay? Substitution. I'm substituting it in for y there, because y equals 2x minus 9. So that will leave me with x plus 3 times 2x minus 9 equals negative 6. Now the reason why you do that is I've gotten rid of the y now, right? So I can solve for x. The only variable in that equation is an x. I'll distribute the 3. X plus 6x minus 27 equals negative 6. Add that together, that'll give me 7x equals plus 27, 21. I'll divide by 7, x equals 3. So x would equal 3. Our next step here is we want to plug it back in to one of the original equations, okay? The easiest thing to do is plug it back into the equation, the line that we've isolated the variable, okay? It's the easiest thing to do because it's less steps. You can plug the 3 in for x and you'll have y. Y equals 2 times 3 minus 9 y equals 6 minus 9, y equals negative 3. So if we graphed those two lines, those lines would intersect at 3, negative 3. Okay? They would intersect at 3, negative 3. So it would be consistent and independent there. It would be consistent and independent. Intersects at 3, negative 3. Okay? Now, the other method will be elimination. Okay? The other method is elimination, and example 2 here. Okay. Again, I'll work this out on the board so you can see me work it. Same thing as in your notes. I'm going to do it the exact same way. I'm just going to talk it out as I do it so you can see it being worked. Okay. So you don't need to write anything down. You can just have eyes up here. We got 3x minus 2y equals 4. And then we have 5x plus 3y equals negative 25. Okay? So the key to elimination is we want to create opposites in either the x or y variable. Okay? It can be the x, it can be the y, it does not matter. You just want to create opposites. So there's a million different routes you can go. Okay? But you generally want to do what's easiest and what you see and presented as the easiest. So like here, we could eliminate the x's, but it would just take a couple more steps. It'd be a little bit longer, whereas it'll be easier to eliminate the y's by just multiplying the first equation by 3 and the second equation by 2.
Would it be negative 2?
Nope. So 3, I'll distribute that 3. That gives me 9x minus 6y equals 12. I distribute that 2. That gives me 10x plus 6y equals negative 50. I have created opposites in my y's. Okay, there we have a negative 6y and a positive 6y. So that when I add those two equations together, it will eliminate the variable y. Add them together, the y is gone. That'll leave me with 19x equals negative 38. All right. Divide by 19. X would equal negative 2. So again here, I can plug that negative 2 into either one of the original equations. All right, Lexi, which one do you want me to plug it into?
The first one.
The first one. So I'll have 3 times negative 2 minus 2y equals 4. So that gives me negative 6 minus 2y equals 4. Add 6, negative 2y equals 10. Divide by negative 2. Y equals negative 5 there. So that solution would be negative 2, negative 5. It would be consistent, independent. If I graphed those two lines, they would intersect at negative 2, negative 5. Okay? All right. So we're going to do substitution here on this first equation, on number 1. All right, so looking at that, what do you think would be the easiest thing to do on number 1?
Get rid of the x.
In the first,
The y on the first one.
right, because it's just less steps, right? So I'm going to subtract 3x, which will give me y equals negative 3x plus 7. Okay. So I'm going to take negative 3x plus 7. I'm going to plug it into y in the second equation. All right, plug it into y there. I'll have 4x plus 2 times negative 3x plus 7 equals 16. I've eliminated the y's from that equation, and I can now solve for x. Okay. First step, I'll distribute that 2. 4x plus negative 6x plus 14 equals 16. Combine like terms. Negative 2x plus 14 equals 16. Subtract 14. Negative 2x equals 2.
X equals -1.
Yep. And divide by negative 2. X equals -1. Okay. So, from this point here to get y, I need to plug it back into one of the originals. And again, the easiest thing to do is plug it into the green equation here where I've isolated the y because it will be less steps. Okay. Plug the -1 in for x. And I'll have y equals -3 times -1 plus 7. So y equals 10. Good. So, answer is -110. Consistent, independent. Try and do substitution on number 2. Try and do substitution on number 2. All right, so first equation, subtract 2x. Give you y equals -2x plus 5. I'm going to take that, I'm going to plug it in for y in the second equation. That'll give me 3x minus 3 times -2x plus 5 equals 3. Now eliminated the y. So I'm going to distribute that -3. 3x plus 6x minus 15 equals 3. Combine like terms. 9x. And then if you add 15 to the right, 9x equals 18. Divide by 9. X equals 2. Okay. So again here, when you plug in, I would plug it into the pink equation right there where we've isolated the y. Be less steps. So that'll give me y equals -2 times 2 plus 5, which gives me y equals 1. So that answer would be 2, 1, consistent, independent. Okay. Do number 3, substitution. Do number 3, substitution. All right, so on number 3 here, the easiest thing to do is isolate that x in the second equation, which will give you x equals -2y plus 2. You don't have to do it that way, but it is the easiest thing to do there, okay? Because then you can take -2y plus 2 and plug it in for x in the first equation. And that'll give you 2 times -2y plus 2 plus 3y equals -3. More than one way to do it, but that will definitely be the easiest. From there, I'll distribute the 2. -4y plus 4 plus 3y equals -3. That'll give me negative y, negative y plus 4 equals negative 3. Subtract 4. Negative y equals negative 7, so y equals 7. Next step there, I'm going to take y equals 7 and plug it back into one of the originals. I plugged it back into the blue equation. X equals negative 2 times 7 plus 2, which gives you x equals negative 12. So the answer is negative 12, 7. It is consistent and independent. Next one's here, we're going to work on elimination, okay? So, if you look at number 4, different ways we can do that. Anyone having a preference on what they want to try and do here? Eliminate the y? Okay. Excuse me. Excuse me. All right. So if I was going to eliminate the y, what would I want to multiply by, Caitlin? Huh?
Would it be 1 for a second?
Not 1.
Or negative 1?
Not negative 1.
Negative 3?
Negative 3. Because if we multiply by negative 3, that'll give me negative 6x plus 3y equals negative 21. And then if I add those two equations together, in this case, the x's will cancel, the y's will cancel. I have 0 equals negative 7. Does 0 equal negative 7?
It does not.
It does not. So, no solution. So it's inconsistent, meaning what kind of lines are these? Parallel lines. Muy bien. Okay. So on number 5, what I think's easiest to do is to clear the fraction. Okay. What would we do to that second line to clear the fraction? Multiply it by 2. All right, so if I multiplied it by 2, distribute that, that would give me 4x minus y equals 8. Okay. What do you notice about these two lines? Huh? They're going to be parallel again, right? Like if you multiplied this line by negative 1, that would give you negative 4x plus y equals negative 8. And if you took that first line, give you 4x minus y equals 6, and you added them together, you get 0 equals negative 2. So again, they'd be parallel lines. No solution, inconsistent. Okay. All right. Well, 6 kind of set up nice, right?
Why did we not multiply the second line on number 4?
You didn't need to. We created opposites by just multiplying the first line. And number 6 is set up nice. Why is it set up nice? Yeah, we already got opposites in the y's, right? We got positive 2y, negative 2y. So we can add them together, and that will give me negative x equals negative 2. So we can divide by negative 1. X equals 2. Okay? So I can plug that back into either one of my originals. Caleb, what do you want me to plug it into? The bottom one with all the negatives. Sounds good. So I'll have negative 6 times 2 minus 2y equals negative 14. Negative 12 minus 2y equals negative 14. Add 12. Negative 2y equals negative 2. Divide by negative 2. Y equals 1. So my answer would be 2, 1. Consistent, independent. That would be where those two lines would intersect. Okay, they would intersect at 2, 1. All right, do number 8 in elimination. All right, on number 8, what variable do you want me to eliminate? Alan?
Wait, what?
What variable do you want me to eliminate on number 8? What would be the easiest there? X or the Y?
The X.
Nope,
The Y.
the Y. All right. And what would be the least common multiple of 2 and negative 3 there? 6. So 6 and negative 6. So what would I multiply the first equation by? 3. So give me 21x plus 6y equals negative 3. All right. And so what would I multiply the second equation by? 2. That would give me 8x minus 6y equals negative 26. Add them together, and I will get 29x equals negative 29. Divide by 29, x equals negative 1. Okay. So now from here, I can take that and plug it into either one of my original equations. Brinley, which one do you want me to plug it into?
I did the bottom one.
Okay. So I'm going to plug it in there. I'll have 4 times negative 1 minus 3y equals negative 13. Negative 4 minus 3y equals negative 13. Add 4. Negative 3y equals negative 9. Divide by negative 3. Y equals 3. So that answer would be negative 1, 3. Consistent, independent. Okay.